Assalamu alaikum rahmatullah. I hope those who are watching this video is having good health and doing great. Welcome to another very important and basic chapter of physics, which is about the effects of heat on matter. And in this chapter, there are a number of important topics and contents that should be discussed and should be understood properly. And there are a lot of mathematical problems in this chapter, so we need to understand each and every content accurately, and then we need to know that how to solve these problems accurately. So this is the contents. I'm just trying to follow the books actually, because if I consider this word as a massive way, so there are a number of another topics will be here, and this will be a huge task. But you see, in these 10 points that I'm trying to listed some sort of like important things that I'll explain, and in this playlist I should try to upload maximum topics with more explanations and with more mathematical problem solution techniques. So you see that number one topic is heat and temperature. So understanding these two words is the key things about this chapter. And then think about thermometric properties. Again, another important things. Relations among different scales. So we know that when we will study about heat, right now I'm trying to focus on these 2 points, and then later on I shall be explaining the following points in different tutorials. So you see that in heat and temperature, when I'll explain it, then thermometric properties, and then relations among the different scales. What are the scales? When we study about temperature, we must know there are 3 scales on temperature. That is Celsius, Kelvin, and Fahrenheit. So okay, we can say it in a different way that Kelvin, Fahrenheit, and Celsius looks like good KFC. And then number 4 is thermal expansion of matter. Another important part. Thermal expansion of matter, it requires 3 type of things, like thermal expansion of solid, thermal expansion of liquid, and thermal expansion of gases. So when I'll explain of it, there are a lot of things inside that we need to understand: the coefficient of linear expansion, coefficient of area expansion, coefficient of volume expansion. So this is very important. And in case of thermal expansion of liquid, we need to understand about the real expansion and the apparent expansion. So these 5 things are really important, and this is about the mathematical explanation included, that like linear expansion alpha, the coefficient of linear expansion of alpha, the coefficient of area expansion, that is beta, and coefficient of volume expansion, that is gamma. So we need to think about alpha, beta, gamma, and these use in case of the mathematical problem solving technique. Number 5, thermal capacity. Most important thing, thermal capacity. Think about C. Then we need to think about specific heat. Then we need to definitely study about the latent heat. And in this case, we need to think what is the latent heat of fusion, which is called LF, and the latent heat of vaporization, that is LV. So usually we will try to understand first the latent heat of fusions in case of water, and latent heat of vaporization in case of water, and the unit and the quantity of these values, that LF is 336,000 joule per kilogram, and in case of LV, that is 226,800 joule per kilogram. So that requires a lot of explanation again. Calorimetry, another ocean, another big area. Calorimetry means that the type of, in the branch of physics where calorie related, the heat related topics will be discussed. Then 4 important things: fusion, vaporizations, boiling, and condensation. We need to understand what are the meaning of this, and then maximum time students face this type of mathematical problems in their question paper, that is mixture temperature. too important. And this type of mathematical problem solving technique, we need a cool head to solve a big numbers of problems regarding the mixture temperature. So focus on that, the list, that what we need to study on this chapter. This is huge. I'm just telling you the truth that, okay, do you understand really what is the content that we need to study in this chapter? That is why I wrote it down as an enlisted point, and then I shall be explaining it serial by serial so that you can understand the sequence. Think about first heat. Well, the first topic is heat. What is the definition of heat? We know, because you already studied in your previous class, that heat is a form of energy which is give us like the sensitivity of coldness or heatness. Simple, like we can say that it's a form of energy. So why it's form of energy? Because following the definition of energy, we can say that the ability of doing something. So that means that heat can do something, like through the heat energy steam engine is performing. So it means, simply speaking, that heat is the form of energy, and that is give us the sensitivity of heatness or coldness. And now what is the unit? So if I say that SI unit of heat is, previously it was, right now it was joule, but previously the unit was calorie. So now the problem is there any sort of relations in between joule and calorie? Definitely. So for first time I want to say that calorie, what is the definition of 1 calorie? So 1 calorie is the amount of heat, that is required to increase 1 gram of water, to increase 1 degree Celsius temperature, that is called 1 calorie. So what is the definition of 1 calorie? So you can say that the amount of heat that is required to increase 1 degree Celsius temperature of 1 gram water, that is 1 calorie. But now if I say that if it is 1000 gram, or we can say that 1 kilogram temperature, to increase this amount of temperature, then it's required 1000 calorie. So this 1000 calorie is actually 1 kilocalorie. So we use kilo as the multiplication of 1000. So in case of food, when we think about the food energy, the amount of energy is required, then we usually use this unit as kilocalorie. So this is the definition. Now what is the relation between joule and calorie? So you must know one thing, that one calorie is 4.2 joule. You must know that 1 calorie is equal 4.2 joule, or inversely you can say that 1 joule is equal 0.24 calorie. Is actually 4.2, or you can say that 4.18 joule. So in both cases these are right. So in case of 1 calorie, you can say that this is 4.18 joule, or 1 joule is equal to 0.24 calorie. So now from this point of view, we understand that the definition of heat, the SI unit of heat, previously it was calorie, but right now joule has been used. And what is the definition of calorie? The amount of heat that is required to increase 1 degree Celsius temperature of 1 gram water, that is called 1 calorie. But in case of 1000, it will be 1000, so it is kilogram, and this is kilocalorie. And this thing, that 1 calorie is equal 4.18 joule, and 1 joule 0.24 calorie. Okay, so now think it. What about temperature? Firstly, think about the temperature is the thermal condition. Is a condition. temperature is a thermal condition. That of course you know the example that is given on your book regarding two different type of beaker, and if it's connected with the water connections, then from which part to which part water will move, that doesn't depend on the amount of water, that depends on the height of the water. Similarly, if two thermal bodies, or if two bodies is having a thermal contact, either it will give heat to it or it will give heat to it. It depends on the temperature. So temperature is a thermal contact of a body that will determine that either this body will receive heat or give up heat if it has a thermal contact with another body. So simply speaking, the temperature is the thermal characters, thermal conditions of a body. So now you think, in case of temperature, what is the SI unit, or you can say that what is the expression, like how we can express temperature. So in case of temperature, we can say that temperature is denoted like theta or T. We usually express temperature by T, but we also can express temperature by theta. Now you think, what is the SI unit of this? In case of theta, we usually use degrees Celsius, or in case of T, we can use Kelvin. So the unit of temperature, partially we can say this is degree Celsius or even degree Kelvin. And this point is very important. I'm coming up with the next video regarding that. Will be the third video, because the second video would be the difference between heat and temperature. What are the relations between these scales, and there another is Fahrenheit. So usually, what is the unit, the SI unit of temperature? We largely use Kelvin. And there is a relation between the Celsius and Kelvin. To understand that, we need to understand one more important thing, that is triple point. Triple point. So think about the triple point. Triple point is the temperature, the specific temperature and pressure where water, remaining at its three states, like solid, liquid and gas. You can say ice, water and vapor. So in which temperature water can remain in three states, that temperature is called the triple point, which is 273.15 Kelvin. Must remember thing. What is the triple point? This should be the questions. It's very common questions on your exam paper. What is triple point? So you must say the temperature where the water remains at its three states, like ice, water and vapor. This is called triple point. And then the question is, what is the definition of 1 Kelvin? Like seriously, this is very, very common questions. That what is the definition of 1 Kelvin? Before going to explain, I'm just giving you some simple example, that if I say that this is the length, which is 5 meter. So now if I make a question that what is 1 meter, then I would say that if it is A and B, and I say this is 5 meter, now I can say the definition of 1 meter is the 1/5 length. The 1/5 length of AB is equal 1 meter, right? Because I know that AB is 5 meter. So if I divide 5 times, then each and every single should be 1 meter. So I can simply say that 1/5 of the length of AB is 1 meter. Right now, as we know that the triple point of water is 273.15 Kelvin. So now the definition of 1 Kelvin is like 1 by 273.15 of the triple point of water is equal 1 Kelvin. So I hope you know what is the definition of 1 calorie and what is the definition of 1 Kelvin. So 1 calorie is the amount of temperature is required, or amount of heat is required. Actually, the amount of heat is required to produce or to increase 1 degree Celsius temperature of 1 gram water. And now the definition of 1 Kelvin is the 1 by 273.1/5 of the triple point of water is 1 Kelvin. So I hope you know about 1 Kelvin. Okay, another important things after this triple point that we need to know, that is thermometric properties. So simply I'm just explaining about heat and temperature very primarily. So you know about the heat, you know about the SI unit, you know about the use of heat, and then also you know about the definition of temperature, you know the unit of temperature. And now one thing important, before going to explaining thermometric properties, I need to say one important thing. If I need to go from degrees Celsius to Kelvin, we need to have idea about the standardizations. In this case, we know that the melting point of pure ice in degrees Celsius is 0 degrees Celsius. And in Kelvin scale, the melting point of pure ice is 273.15 Kelvin. And now you think the boiling point of pure water is, according to Celsius, is 100 degrees Celsius. So in case of Kelvin, the boiling point of pure water is 373.15 Kelvin. Now you think about the differences. Here the difference is 100 unit, and also here is the difference is 100 unit. So in both cases, in case of Celsius and Kelvin, the differences are same. So you understand this is same, but in this case, individually, when you see that 0 degrees Celsius is equal to 273.15 Kelvin, but in case of differences, these are same. Now you think about it. If question is given like what is 5 degrees Celsius in case of Kelvin, then what we need to do, if I need to convert this Celsius to Kelvin, we need to think that this 5 plus 273.15. So that is actually 278.15 Kelvin. If I say what is the Kelvin scale in case of 10 degrees Celsius, so we can say that in case of 10 degrees Celsius, the Kelvin could be 283.15 Kelvin. What is the meaning of if it is minus 10 degrees Celsius? Then we need to deduct 10 from 273, and then this would be 263.15 Kelvin. So simply, what is the meaning of Kelvin from Celsius? So if an individual Celsius temperature is given and we need to convert it to Kelvin, we need to add 273.15. But so before going to explain it, one thing is important. So it says that theta degrees Celsius, if it's given theta degrees Celsius, that means we can say that theta plus 273.15 Kelvin. But in case of differences, if I say the differences is 10 degrees Celsius, difference is 10 degrees Celsius, in case of difference, it will be same 10 Kelvin. Why? You see, I just come across from 0 to 100, which is 100, and come across from 273.373, this is again 100. So in case of difference, Celsius and Kelvin should same. How? It's like, see this, if I say that 50 degrees Celsius minus 30 degrees Celsius is equal 20 degrees Celsius, okay, and that is also okay 20 Kelvin. In this case, we should not add 273. it doesn't mean that 273 plus 20 will be 293.15 Kelvin. No. This 20 degrees Celsius is the differences between Celsius. So if I need to find it out, we need to add 50 plus 273.15 in case of Kelvin minus 30 plus 273.15 again Kelvin. So we will get again 20 Kelvin here. So I hope you get it. So in case of differences, the Celsius and Kelvin are same. In case of differences, that is why, because in both cases, that when it's differences, both quantity we need to deduct 273. So it's same. Okay? So I'm giving you some basic idea that why we need to add 273.15 when we need to convert from Celsius to Kelvin in single cases. But in differences, things will be same. Now come to thermometric properties. Okay, I'm just removing it. So what is thermometric properties? Thermometric properties are the properties of matter which is changed due to the change of temperature. It means that, the properties that is changes, and we can measure the temperature from the change of the properties. Those properties are known as thermometric properties. What is thermometric properties? So if you see that what is the definition, written definition of your book regarding thermometric properties, think about the thermometer. What is thermometer? Thermometer is a mechanical substance or a machine that can help us to determine the temperature. In case of thermometer, we can have mercury thermometer, we have gas thermometer, we have alcohol thermometer. So how we do measure the temperature through the thermometer? When the height of the mercury is expanded into the capillary tube of thermometer, it gives us the idea that what is the degree Fahrenheit or degree Celsius. So that is thermometric property. So in this case, thermometer, inside there is mercury. So this mercury is a thermometric substance or thermometric matter, but the expansion of its volume is the thermometric property. Not every case is thermometric properties, like in case of gaseous thermometer, the expansion of volume of gas is the thermometric property, and that gas which is using to determine the temperature, this is thermometric substance. Okay, so now you think about thermometric properties like resistance also, because suppose one thing is important, like thermocouple. In case of thermocouple, what is going on? In case of thermocouple, there are two legs, okay, positive and negative legs, two different type of, like in case of type E thermocouple. In case of type E thermocouple, you know that two legs will be used. Number one is chromel as a positive leg, and constantan is used as a negative leg. So in case of chromel, nickel plus 10% chromium is used, and in case of here, nickel plus 45% copper is used. And these chromel and constant is used as two different junctions of two metal, and that is actually used in various wide aspects in case of industry to determine the temperature. So this thermocouple is a good example of a thermometric properties or thermometric substance. Like chromel and constantan is used in case of determining the temperature. This is two different type of metal that is used to determine the temperature. So this is thermometric properties. So what is thermometric properties? The properties which is changed, or by changing these properties we can actually determine the temperature, and those properties are, doing it, this is thermometric property, and the substance is known as thermometric substance. So I hope you understand the primary lecture on this chapter about heat, temperature and the thermometric property. So what we actually studied in this topic, in this tutorial, first heat, temperature, SI unit, thermometric properties, and what is the difference between degree Celsius to Kelvin. So I hope that those who are watching these videos, please, it's getting longer video because I'm trying to give you more and more information from my best end for the students, those who are watching right now. And if you have any feedback, just put it some comments in the comment section so that I can understand your vibrations. And from any corner in this world as you are watching these videos, I'm appreciating your efforts that you are watching these videos, and I wish that you can have some sort of contributions in your study life. So see you in the next class regarding the relations among different scales and the difference between heat and temperature. And I'm coming up with the next videos with these contents to give you a package regarding these topics. And this chapter is important. And I hope you won't miss any topic or any tutorial under this playlist. See you. Take care.